Hi there, welcome to the Compound Inequalities practice set. Please like this video if you find it helpful and subscribe for more math content and drop a comment or a question below. As always, pause the video to work these problems on your own and then come back to check your work. All right, so these first two problems are just getting at your fluency with being able to move between different ways of writing these inequalities. So the first one is write as a single inequality, and we have x is less than or equal to 5 and x is greater than or equal to -3. And so that would be one of our and inequalities. It might help for you to picture it. So we have the 5 and we have the -3, and we know that x has to be less than or equal to the 5, which means we're going to be going in that direction, and it must be greater than or equal to the -3, which means we're going to be going in that direction, and that can give us maybe a visual to help us see what the single inequality would look like. And it would be -3 is less than or equal to x is less than or equal to 5. Now this one is a single inequality. -6 is less than x is less than -1, and just write it as two inequalities. And so we've got this inequality right here, which we would write as x is greater than -6 and x is less than -1. And you would want to conjoin those with the word and, okay? X must meet both of those requirements, not one or the other, which would be the entire number line, but both of them. Okay, these next ones are just to solve, and so we have -3 is less than or equal to -2x plus 1 is less than or equal to 5, and we're going to begin by subtracting 1. We have to subtract 1 from everywhere. -3 minus 1 gives me -4, or if it helps, you might say -3 plus -1. -2x plus 1 minus 1, well, plus 1 minus 1 cancel each other out, leaving me with -2x, and 5 minus 1 is 4, and then we'll be dividing everything by -2. Now remember, when we divide by a negative, we have to flip the inequality there. So we'll have -4 divided by -2 is 2, is greater than or equal to, -2 divided by -2 is 1, so I'm left with the x, is greater than or equal to 4 divided by -2 is -2. And typically we would do the rewrite, okay, just to get those from going from least to greatest. So -2 is less than or equal to x is less than or equal to 2 would be the more comfortable way of writing that. Second one is an or inequality. So we have 3x plus 4 is less than 7, or 3x plus 4 is greater than or equal to 25. But it can't be both, okay? It can't be both less than 7 and also greater than 25, okay? That's not a thing. So we'd start by subtracting 4. So this will give me 3x is less than 3. Divide both sides by 3, and I get x is less than 1. Or coming over here and subtracting 4 gives us 3x is greater than or equal to 21, and dividing by 3. And remember, there's no flip there because you're not dividing by a negative. And we get x is greater than or equal to 7, and that is or. So x is less than 1, or x is greater than or equal to 7. Graph this one. So for number 5, we are going to graph it. Keep it simple. Only put the numbers on there that you care about. So we have -200 and 300. X needs to be between them, and the -200 is included, and the 300 is not. Now, you might do it this way. We talked about this in the video on what inequalities are, where you might do the bracket at one end and the parenthesis at the other. And that is leading into a different kind of notation. So it's not bad to see it, just kind of file it away under, I will see that in a future math class somewhere. Now, question 6, I actually provided a clarification for this because of the way it's phrased. Is x equals 3 a solution for? And then I put it in quotation marks. 2x plus 1 is greater than 4, or 2x plus 1 is less than or equal to -2. And the way a lot of students would answer that is they'd check both of those, and then they would tell me which one it worked for. But really, that's a compound inequality. So it's either yes, 3 is a solution, or no, 3 is not a solution. If 3 meets either of them, then the answer is yes. If 3 does not meet either of them, then the answer is no. And so we would look at this, and we might say 2x plus 1 is greater than 4. So we plug in the 3 to check, and we get 7 is greater than 4, which is true. Therefore, the answer is yes, it is a solution. It does not have to work for both. In fact, it can't. So if 3 does make this first one true, then it by definition can't make the other one true. Okay, so it can't, the 2x plus 1 can't be both greater than 4 and also less than -2. Now you might be thinking, well, all the ones that you've done, you've had the same expression. So 2x plus 1, or I think we did one, it was 3x plus 4 or whatever. Are they ever different? Rarely, because in most real life contexts, if you are dealing with, like we talked about the example of like the vitamin D levels, if you need to go back to the lesson, please go back to that. You're going to be dealing with the same formula. Like you're not all of a sudden changing formulas in the middle of a problem. Could somebody do that in a math class? Yeah, they could just change it up, but realistically, outside of like a math class application, you're going to be dealing with the same problem and the same formula. I won't say that's 100% of the time. It's just a lot of the time. Okay, question 7, write an inequality to express what grade you need to earn a C in algebra. Now, this might be different for different schools, but we talked about this in another video. We might say 70 is less than or equal to X is less than 80. Okay, so you've got to be below the 80, but above or equal to the 7. In other words, like the number has to start with a 7. Okay, if the number starts with a 7, you have a C. Some schools do have different thresholds for that. So I know some schools, like you need a 75 to get a 7. And then you've got the whole rounding thing that might go on. So you might have 69.5 is less than or equal to X is less than 79.5. You could do something like that if your teacher or your school rounds. The important thing with this problem is that you know how to take that situation and write an inequality for it. And the last one is more independent. Just do an internet search to find more examples of compound inequalities. Like, where do these things turn up? And so I did a quick internet search and came up with this, saw this, so screenshotted it. What are inequalities used for? Age restrictions on things. So you must be 16 years of age or older. So X is greater than or equal to 16. Construction, I mentioned in the video, that, the tolerances. Finance, I read through this website, looked at some of the finance stuff. Manufacturing, limits on labor, time, and materials. So you might have even something where like you have to work a certain number of hours in order to be considered full-time, but if you go past a certain number of hours, now you have to be paid overtime. And so you might see a compound inequality there. We mentioned medicine, real estate. So they have a minimum lot size or home area. So if you're looking to build on a particular piece of property, you've got a certain range of things that you can work with. And so if you're interested in checking that out, I did have the link there, and I will post the link to that website in the description box so that you can go and check that out if you would like to see some, if you were not successful in finding some examples on your own. All right. Well, don't forget, please like and subscribe for more math help. Check out some other videos on the channel. We do have some other playlists and content areas, things that you might find helpful, and drop a comment or a question below. Let me know what you think, and I will see you in the next one.